In this video segment, we're going to take a look at problems 2 and 3. So problem number 2, I gave you some information about BJSG Ribs in Mankato, Minnesota. This is clearly a fictional firm. It's in a market where there's a labor-demand relation of labor demand is equal to 75 minus 6W. I've told you to assume that it's a profit-maximizing firm in a competitive labor market and a competitive goods market with numerous employers, and that all firms have the same labor-supply relation. It really didn't matter what that labor-supply relation is in this part of the problem, or actually for this problem at all, but I just let you make that assumption. What's important to us at the moment is labor demand is equal to 75 minus 6W. And then I ask you to fill out this table that you've gotten used to seeing. And I gave you the wages, and then I gave you the quantity of output of the goods being produced. And you had to fill in labor demand, marginal product of labor, price of the output good, and marginal revenue product of labor for this part of the question. Well, labor demand is going to be filled out very simply. If you take the wage of 6 and plug it into the labor demand equation, it will give you the number of units of labor demanded. And I think virtually everyone got this correct. So I was pleased with that. This would have started at 39 and then decremented down to 15 as we put in 10 into the labor demand equation. 75 minus 6 times 10, or 75 minus 60 equals 15. So that was fairly simple to do that part. To get the marginal product of labor, then you had to go ahead and identify the change in quantity divided by the change in labor. That's the marginal product of labor. And so the change in quantity, we go from 175 to 170, so that's a negative 5. By the change in labor, we go from 39 to 36, or negative 3. So negative 5 divided by negative 3 is 1.67. So that's our marginal product of labor. Some of you gave me a marginal product of labor here, and some of you just gave me a number that I don't know where you came up with it. It's as though you had supposed what the quantity was when a wage was 5. You guessed that, I suppose. Some of you actually gave me the 1.67 here in the first space, so you just kind of shifted things by one row. That cost you a little bit, but not much. And if you gave me the wrong quantity or the wrong item here just because you guessed, I don't think it cost you something unless you gave me the wrong values here. But I would caution you against making up values. In order to give me a value in this space, you had to make up a value for quantity based on some amount of labor or wage, which would have begat some amount of labor. And it would clearly have been a guess in that case. So that's the marginal product of labor, and we started at 1.67. We just carry that down, and it would have ended at 4, and we're increasing. So the marginal product of labor increases as the quantity of workers decreases. Well, that doesn't surprise us. In fact, if it had been the opposite, that would have surprised us. So the price of the output good, I tell you here, is ribs. Price of ribs is $3 a unit. It's a consistent price. It doesn't change. And we know it doesn't change because this is a competitive goods market. And I've instructed you that when we have a competitive goods market, the market sets a price for the good, and all sellers that are going to successfully sell will sell the product for that price. And then the marginal revenue product of labor is equal to the marginal product of labor times the price. So that becomes then 1.67 times 3, or 5.01. 2 times 3, 6, and so on. What we get to, if you're looking at this carefully, is we get to a point where the wage can be observed to be virtually equal to the marginal revenue product of labor. Recall that this is a profit-maximizing firm in a competitive labor market, and that condition is going to be marginal revenue product of labor becomes equal to the wage. So that's what we're looking for, and this, by the way, is going to set up for us the number of workers to employ and the wage at which to employ them. Some of you went ahead and gave me a total cost of labor and a marginal expense of labor, which I thought was interesting, but the marginal expense of labor would have remained constant if this was a competitive market, because the wage in the competitive market would have been set at 8. That's why I didn't take you there within this particular problem. So as we go on to item B, within this, we then are asked to identify the number of workers that you would employ and the wage at which you would pay them. And again, that was 27 and 8, as I said for part A. And then in part C, I give you the marginal product of capital at the number of workers you've indicated. Well, the number of workers was 27. And I've said the marginal product of capital there was equal to 9. And the price of capital was equal to 30, and asked you to recommend some level of labor or some relationship then that the firm would have to meet for this to become a profit or to be a profit maximizing firm. I was looking for you to come up with a balance condition where the marginal product of capital divided by the price of capital is equal to the marginal product of labor divided by the price of labor. And the price of labor, of course, is the wage. Well, we know that the wage was 8. And we know at a wage of 8, the marginal product of labor was 2.67. So we can see that 9 divided by 30, or marginal product of labor or capital by the price of capital, 9 divided by 30, needed to be equal to 2.67 divided by 8. And it's not, because this would suggest that 0.3 is not equal to 0.334, and it's not, of course. So if that's the case, what do you do to solve the problem? Well, we can solve the problem by changing the price of capital. No, I don't think that in a competitive market we can set the price of a good. We can't set the price of capital, nor can we set the price of labor. These are competitive markets, I've told you. So we are price takers, not price makers. In the short term, we really can't change the marginal product of capital. To do that, we'd have to introduce more capital into the firm or take away capital. You don't do that quickly. That takes time, planning, financing, etc. So that left us with the only thing we could change is the marginal product of labor. And as managers then, if we want to go ahead and bring these equations into equality, since the right-hand equation is too large, we need to reduce the size of the numerator. To reduce the marginal product of labor, we then need to increase the number of workers. So to bring this into equality, we're going to increase labor and decrease marginal product of labor. And then I've said, okay, fine. Now what would be the implication of the adjustments you've recommended in C to the relationship between W and MRP of L? Well, if we reduce the marginal product of labor, we're going to reduce the marginal revenue product of labor, in which case the wage that we're being required to pay in this market where we are a wage taker, the marginal revenue product is now going to be less than the wage, and that's going to give us some kind of a problem. We're going to be operating outside of profit maximization. So we have a little bit of a catch-22 here, a little bit of friction that we don't immediately see how to deal with. And that was question number 2. Question number 3 is a labor-leisure model, labor supply, labor-leisure model question. Here we have John, college graduate, mid-level executive in a technology storage firm with lots of experience. He's making $40 an hour at the firm. He has some investment income or some endowment that gives him $50 a day, and I've told you that's going to equate to $250 a week. His daily budget requirement is $400 a day or $2,000 a week. And he's a supervisory employee. He doesn't get any overtime, so you're not going to observe an overtime kink in his budget curve. His employer lets him work and pays him for as many hours as he'd like to work, but only allows him to work 5 days a week. I said that so that we can constrain this model to something that's reasonable for you to fill out. So I then asked you to give me some graphic representation of John's model here, or what we're looking at, under the presumption that John experiences an increase in wage, I think it was. Let me confirm that. Yes, if his hours remain constant and his wage increases. So what's this going to look like? Well, to set it up, you must first recall that this becomes a labor-leisure model. You've seen this before. We have leisure that goes from 0 to 16. We have labor that goes from 16 to 0. You could have done this just the opposite, where you put labor first and then leisure, but you had to make sure the numbers were right. And then we know there's a $50 endowment, so we've got a line going straight up here at $50. And then from there, we know that he gets paid $40 an hour. And so we're going to take 8 times 40, which is 640, add it to 50, which tells us this curve is going to then transect the y-axis or the income axis at 690. And that's going to become John's budget curve. We see there, to meet his $400 daily requirement, he must work 8.75 hours. So 8.75 times 40 plus 50 becomes his $400 daily budget need. But if we see an increase in his wage, which simply is going to increase the slope of his budget curve and is going to then cause it to transect the y-axis at something greater than 690, we don't know exactly what it is because we don't know exactly what the wage is. We just said it's greater than $40 an hour. If he's going to work the same number of hours, then he's going to end up with more than $400 because he's chosen to work the same number of hours. He's going to get more income, which means he's going to go from an indifference curve representing his level of utility that transects or is tangent to the original budget curve here. It's going to shift it such that it's here, and we know that as the indifference curve shifts out and to the right, that there is a higher level of utility. So this is what I was looking for, and some description here to help me understand that. Part B then for this, I say assume John is a participant in a competitive labor market, that the marginal output, and that the output price of the firm's good is $1,200. So that's P. So P equals 1,200. And I say, what can you tell me about his weekly marginal productivity? Well, what are we looking at here? We need to find the marginal product of labor, and the only way I know to do that in this case is to think about W, his wage, being equal to something. I know we said that was equal to some dollar amount. Well, it was equal to $1,750 if you take the wage that he's earning, and that would then be equal to the marginal revenue product of labor, which is equal to the marginal product of labor times the price, which we know is $1,200. So now, in order to find the marginal product of labor, we can simply take the $1,750 wage, divide it by 1,200, and it will equal the marginal product of labor, or that's 1.458. And that's how you do item B. Item C, I've asked you to give me the graph again. In fact, a number of you realized it's virtually identical to part of what I was asking for here, so it's very simple for you. So to give me the graph again, we have the same leisure, labor, 16 and 0, 0 and 16, 7 and a quarter, 8.75. We know we calculated 8.75, of course, to get to his budget requirement. We knew that he had a $50 endowment and that he needed $400. Well, the difference between 50 and 400 is 350. 350 divided by the $40 wage is 8.7 hours of labor each day. If there's only 16 hours available, that left 7.25 hours for leisure. And so we had identified his budget curve. And I asked you to give me some representation of John's tastes and preferences, and that is an indifference curve. That's item C. And then item D. Given what you know about John, how would you describe his relative skill set and his overall level of utility? Well, if he's earning what we suggest he is, and he's earning around $90,000 a year. That means we've got relatively highly skilled worker here. I don't know about you. I think $90,000 a year is a decent wage. Some of you do or will earn much more than that in your careers. Many of you don't earn that yet. But $90,000 is at the very least a decent wage. You can live on that. But you can't get it at a low skill set. You must be relatively highly skilled. And then we would expect a relatively high level of utility as well, because if he's only working 8 3/4 hours a day, some of you made the comment you thought that was a lot. I'm here to tell you that's not. A lot of work a day is 12 to 16 hours. A little over 8 hours a day isn't a lot of work, so he's got a lot of time for leisure. And he's got a fairly good amount of income, so a lot of leisure time, good income should be a high level of utility. And that's how we looked at questions 2 and 3.